All right. Thank you. Hi, Akila. Good morning. So which one do you want me to go through, Akila? The mic is not working, is it? Oh, you're on the way. Oh, okay. I thought you're not being physical. I am not. I'm not there actually. Akila says she's still in the car. She's on her way. I thought she's like at home and not coming. Did anyone else say that they are positive or something?
So far okay, sir. Nada
okay.
positive.
All right, okay, that's good then. Okay.
You okay, sir?
Yeah, I mean the worst of it was Monday, and then today okay already. But just need to get tested tonight and see how it is. I mean, it's just normal now, right? Everyone just getting it.
Okay.
Yeah. Oh, good. No worries. Okay. Hi, Akila, are you still in the car?
Yes, sir.
Are you nearby?
Yes, on my way. 10 more minutes.
Okay, it's all right. I mean, like, you can ask me to go through anything. I mean, the session is recorded anyway, so I don't mind going through stuff and you can watch later. But is there anything in particular you want me to ask? Because I'm only here, 8:30 until 9:30, so. Is there anything in particular you want to ask? Because you know the class started at 8:30, right?
Yes. Question 3 about the how to explain the graph for the first order.
Question 3, first order. What paper did I give you? Did I give you the May June 2022 paper 4.2? What does it say on the
Sorry,
paper? What paper did I give you? What paper are you talking about? Talking about the March or the June 2022 paper?
The June 2022 for 41.
41. Okay, I thought I gave you 42. Okay, never mind. Let me just try and find that other paper. Yeah. Yeah, the paper has just been released yesterday. Yeah, so you should be able to download it online already, including the marking scheme as well. So yeah, I mean everyone will have access to the paper now. Question 3. Yeah. Okay. Yeah, let's see. Let's see what do I have here. So how do you determine whether it's first order or not, right? So, I mean, you already done the first bit. So in order to show it's first order, you need to know that first order reaction has constant half-life. So the most important thing is first order reactions has constant half-life, and you gotta show using the graph. So what do you understand by half-life? What do you know about half-life, Attila?
Half the time of the reaction.
It's not half the time, it's the time taken. It's the time taken for the initial concentration to half. So the initial concentration is here is 0.02. So when you half that, you're gonna get 0.01. So that means if I find the x-axis value, so from here to here, I mean from the initial time to 0 to there, give or take, if you know how to estimate, that one should be halfway in between, around 37.5. So I would say this is probably around 30, give or take. So this is around 30 seconds. So that is called the first half-life. The first half-life is 30 seconds. You're trying to show constant half-life, not just from the first one. You also need a second one. So I'm going to half that again. So from here, now I'm going to start from here. I will half it again. That will give me 0.0050. So I'm going to half it again. And then from here to here, you will see that from the 30 seconds to here, this give or take is around 60 seconds. So that region there is 60 minus 30, which is another 30 seconds. This is your second half-life. You get it so far?
Yes.
So your job really is to show that this is not, the whole 60 seconds is not the half-life. It's from here, 30 to 60, because your concentration fell down from 0.01 to 0.0050. It's the time taken for the initial concentration to half. It's the time taken for the initial concentration to half. So what do I write in my answer? I write the statement, I use the graph, and I said that the first half-life was 30 seconds. The second half-life, of which I've already shown on the graph, so that was also 30 seconds. So therefore, that is first order. So first order reaction have constant half-life, yeah? And this is with respect to whatever that was changing. That is just the concentration of the tertiary halogen alkene. Okay? All right, your next question. You okay with the next bit or stuck as well? I mean this bit. Oh, are the others there with you already?
Yes.
All right, okay. I'm not sure. Do you guys have the computer stuck onto the TV? Like you can see my screen, all right?
Yes.
All right, okay, cool. Just let me know which question you want me to go through.
Question 1, sir.
Question 1. All right. I'm going to go through this very quickly. What about question 1? The whole thing?
Part D1.
Sorry? Part B. Are we on the same paper? Okay, I thought you said B part 1. All right. Now, what do you observe? This is only 1 marks. And this is with excess of value sulfuric acid. If you look at the first part of the question, this is about solubility of sulfate. You know that barium sulfate is going to come out as a white precipitate. And you also know about magnesium sulfate being slightly soluble. So what you're going to observe will be colorless solution, because you know you don't get colored precipitate or whatever, but here you're going to get a white precipitate. Oh, there you go. That's it. I mean, test for sulfate, you add nitric acid and you add barium nitrate, you're going to get a white precipitate, paper 3, which they can ask you in paper 1, paper 2, as well as paper 4. Okay? Everything all good? Sorry? D, is it? Oh, D. Oh, okay. I heard you say B. Okay, should have stopped me earlier. Okay, this is a Haber cycle. You should have your paper with you anyway. So they want you to calculate the enthalpy change of formation of the SO42 minus. This is lattice energy. So it's exothermic because you are forming the lattice. So I would imagine that the first thing I would need to do for these 3 marks is to draw my Born-Haber cycle. Born-Haber cycle you can draw various ways. Okay. So what I'm going to do is I'm going to start from lattice. Okay, so why is this one called lattice? Because you have gaseous ions coming together to give you the solid, ionic solid, right? So that is your lattice. There should be no problem. Usually we start from elements. So I will have barium as an element. There is a solid, and I'll have sulfur as an element, which is a solid, and I'll have O2 as an element, which is a gas. Everything must be balanced. So I've got 4 oxygens. So I need 2 O2 there. And this must be the formation, because forming 1 mole of the substance, enthalpy change when I form 1 mole of the substance from its elements, everything in standard states under standard conditions. Now the job really usually is you atomize. But let me see. So there is atomization of barium. There is atomization of sulfur. But there is no atomization of oxygen, right? Only 2 atomization. But there is this thing called bond energy. There is a relationship between the bond energy of some elements and their atomizations. Because what does bond energy in AS mean to you? In AS energetics, bond energy is in kilojoule per mole. Kilojoule per mole. It is the energy required to break 1 mole of the covalent bonds into gaseous atoms, everything in standard states, This is also 2 times the atomizations of oxygen. Why? Because atomization is an A2 definition. In A2, if you look back at your syllabus where it says candidate must be able to define atomization of oxygen or atomization of anything, it is the enthalpy change when I produce 1 mole of the gaseous atom from its element in its standard states under standard conditions. So this thing is going to give you half of O2 gas, giving you 1 oxygen gaseous atom. Hence, because I'm making 2 oxygen gaseous atom from its element in its standard states, this thing is going to be 2 times the atomization of oxygen. So yes, they don't give me the atomization of oxygen, but they give me the bond energy of oxygen. But I can get the atomization of oxygen by moving the 2 to the other side. So half of this value is going to be the atomization of oxygen. Happy with that first step?
Yes.
I mean, that is the most important thing that you really need for this question, to be honest. So from there, I'll get 4 oxygen gaseous atom. So here I will have 4 times the atomizations of oxygen, which is going to be 2 times the bond energy. So it's just going to be 2 times plus 496 because I'm breaking 2 mole of the covalent bonds into gaseous atoms. Here is breaking 1 mole. So I'm breaking 2 moles, so I have 2 times that. And then the sulfur atomization going from the solid to the gas, there's plus 279. Oops, plus 279. The barium, on the other hand, is plus 180. Atomizations, plus 180. From here to here, this is your first ionization energy and your second ionization energy from AS chemistry. So first and second ionization energy, plus 503 and plus 965. So that is Ba plus gas, that is plus 503, and then there is plus 965. Second ionization energy, this is first ionization energy. Now what do they want us to do? They say sulfur solid. Oh, bugger, we have just wasted our time, by the way. You see this? This one is the formation of SO42 minus gas. So guess what? The formation of SO42 minus gas, we don't need any of these. So despite this being what we normally do for the normal lattice enthalpy, we should have read the question earlier. Sulfur solid plus oxygen gas plus electrons, giving us SO42 minus gas. Sulfur solid plus 2 oxygen gas, giving us SO42 minus gas. So all of this is not necessary. Guess what? This goes all the way to this. So that one is the formation of SO42 minus. That is what they want you to find. Do you agree?
Yes.
Oh, there you go. So it's much simpler now. So the lattice enthalpy is minus 2469. Because if you read about it, it's from the elements forming this. It's whatever they give you. Okay. So if you can follow the Hess law, this is going in the same direction. This is going in the opposite direction. Can follow the pink arrow?
Yes.
So this plus this plus this plus this and this is equal to the other one. So if I put a number to them, this is just random numbering. 1, 2, 3, 4, and 5. So what I could say is 1 plus 2 plus 3 plus 4 is equal to 5, because in the same direction, add them up together. In the opposite direction, add them up together. I want to find number 3. So 3 is equal to 5 minus 1 plus 2 plus 3. Now I'm just going to put in the value, which, you can just put in number 5, which was, hang on, where's number 5? Formation of barium sulfate minus 1473. This is minus 1473. I think you should have no problem putting in your own value, but I'm not going to do the final calculation for you. That one you can do yourself. Hang on, what have I done? No, there should be 4. Yep, there should be 4, because I want the 3, so I want 2 and 4 move to the other side in the big bracket. Number 4 is minus 2469. Press your calculator correctly. You should get a final answer. Make sure you have a sign. Make sure you have a value. Make sure you have a unit. For that 3 marks, 3 minutes, done. Okay, next question. Ideally, you guys should have done this at home, right? Because you have had the paper for the whole week. So go on, next question.
Part 2, D part 2.
D part 2. Okay, so cesium is group 1, barium is group 2. If you have a look at the periodic table, I just need to see where cesium and barium is. Do you see that cesium is just before barium? They're in the same period. At the back of your periodic table, do you see it? Do you have a periodic table? Okay, so this is group 1, this is group 2. So AS chemistry should have taught you about atomic radius. Atomic radius decrease across a period. So this is third period chemistry, Na all the way to chlorines. We know that the atomic radius decreases. And we also know that ionic radius, so the Na plus will be there, and then Mg2 plus will be there, something like that, right? I'm sure you've seen this in AS, not A2. The ions, the positive ions, are smaller than the atom. So what happened then is, this is ionic. So cesium plus versus barium 2 plus. So they're in the same period. So which one is going to be bigger, cesium plus or barium 2 plus? What do you think?
Barium.
See, different answer, right? I don't know. I don't know. I mean, this is AS. This is two elements forming the ions from the same period. So cesium plus is going to be bigger. Cesium plus is bigger than barium 2 plus. We're not talking about the atom, yeah. We're talking about the ions. Lattice energy to do with forming the ionic bond, yeah, from the ions. So what happened then is, if that is bigger than that, and that's number one. And then number two, +1 charge on cesium plus is smaller than +2 on barium 2 plus. In your syllabus, there is something called charge density. Charge density matters because charge density is charge over size or charge over volume. So what happened then is, what can you comment about the charge density of cesium plus? Is it going to be bigger or smaller compared to barium 2 plus? So the charge is smaller, but the size is bigger. So what happened to the charge density of cesium plus? Is it going to be bigger or smaller?
Smaller.
Smaller is correct. So that means your charge is not as concentrated, yeah? Yeah, if your charge is not as concentrated, do you think your ionic bonds with sulfate is going to be stronger or weaker? So charge density means how much charge you have in the size, in the volume. You are attracted to negative charge. So if your charge density is smaller, not as concentrated, will your ionic bond be stronger or weaker? Does it form stronger or weaker ionic bonds? What do you think? Are you guys still there? Oh no. You guys got disconnected. You still there, Akila? Have you arrived, Akila?
In the lift, sorry, I'm going upstairs now.
Okay, I think the BIBD Alaf was disconnected just now.
Recording in progress.
Oh, okay, you guys are back online. Okay, I don't know, you guys were disconnected just now. So I was just saying about charge density of the cesium plus. So that is smaller than Ba2 plus. And so the charge is not as concentrated. If the charge is not as concentrated, will it form weaker or will it form stronger ionic bonds with the negative charge sulfate? So it form weaker ionic bonds. If you form weaker ionic bonds, so that means you are not as exothermic with your lattice. So your lattice will become less exothermic. So this is CH2SO4 will be less exothermic. But then they want you to talk about the barium sulfate. So I could say the other way around. I could say the barium sulfate one is more exothermic because there will be stronger ionic bonds. Make sense?
Yes.
Okay, cool. All right, next question. Come on, we don't have all day. Maybe another half an hour. Any questions? I don't think you guys actually did the full paper. Because if you did, you already know which questions you don't know how to do. Anyway,
Six.
number 6 is it?
Yes.
Yes, 6.
Hmm,
Alright.
number 6 question part berapa? The whole thing?
B.
6B. Have you guys finished NMR in school yet?
Yes, baru.
Oh,
Just-
baru, okay. So you should be able to do NMR then, okay? NMR is about symmetry, yeah? So you need to think about symmetry. So we use deuterated solvent. These are what we call deuterated solvent. Now we use it as a solvent because there has no protons, meaning to say they don't have that, and therefore will not appear in the proton NMR of your sample. So that means we just use it to dissolve the substance that you want to dissolve. We want to investigate these protons. We don't want our solvent to interfere with the result of these protons, so we use deuterated solvent. Now we use carbon-13. Carbon-13 looks for carbons. Proton NMR looks for, well, protons, look for all these H. Now, first of all, this molecule is not symmetrical. This side is carboxylic acid. This side is an amide. So this left and right are not the same. Okay, that's the first thing. This has NH2, this has NH2, but this has C double bond or this doesn't have C double bond or. So really none of these are the same. So you got 1, and you got 2, you got 3, 4, and 5. 5 different environments. Can you follow that?
Yes.
Yes.
Okay. Now for carbon, look for carbon. I'm going to use highlighter. 1, 2, 3, 4. Only 4 carbon. They are different. Okay, all done. Next. Oh, I have another one. There is another question. If I add D2O, how many disappear? How many signals disappear? If you learn D2O, D2O will do fast exchange. Fast exchange of what? Fast exchange of labile protons. This is called labile protons. Protons that are easy to come off. And as stated in the syllabus, they refer to the OH and the NH. So both these OH and NH, they can come off easily. They are called labile protons. Make sure you can spell them, yeah? L-A-B-I-L-E. Labile proton refer to OH, sama NH, yeah? So what happened is, these two, they can come off easily and they will disappear if you add D2O. So what happened is, the D, which is a heavy isotope of hydrogen, it will replace the H. When the D replaces the H, that means no more H. For example, this is NH2. NH2 will become ND2. And when it becomes D, it is no longer H. This signal will disappear. Do you follow the idea?
Yes.
Yes.
What else? So how many signals will disappear apart from this one?
3.
5.
Because here, here, and here. Can you see that?
Oh, and
3.
yes.
Can you see that? So the
Yes.
OH and the NH, okay? So be careful, okay? All right, next one. Any other questions?
Seven.
Sorry,
D. 7 part D.
7 part B. Oh, there you go. You can do this question now. Why don't you try and do it? 7B, right? Okay, well, let's see. It wants you to predict how many proton NMR you see when you dissolve in D2O. So this one is procan. So we are looking at procan, right? Any labile proton here?
Yes.
Where is it?
The
Ada?
about NH2.
Okay, so this one will not appear. So this is the only one do not count. Okay, now after you do that, then the rest everything counts. Can you see there's a symmetry, there's a mirror plane down there? So it means that this side is the same as this side because the molecule can flip. Whatever is here will be here because you can freely rotate anyway. But whatever is here is the same as that because you can flip back and forth. Happy?
Yes.
Okay, whereas this one is the same as this. Happy with that?
Yes.
Okay. Is there a proton here?
No.
Is there a
No.
proton here?
Yeah. Yes.
No.
Yes.
No. If there is no proton there, there is no proton there also. C6H6. Ani kena substitute already. You substitute 1H with this group already. So no proton there. No proton. Do not miscount. Okay. sp2 to sp2 carbon. Now, is there any proton here?
No.
No.
No. So the next one will really be these, and then the green ones. Okay, how many different protons are here? CH2, CH3 twice. How many different protons are here? CH2, CH3, CH2, CH3, right? Two of them. So how many different protons are here?
4.
That would be wrong. You see this molecule can rotate. It can rotate around. Yeah. It's not fixed. You can rotate around. You can rotate this way, you can rotate this way. So essentially, what you're looking at really is this is the same as that. Can follow? Okay. And then you're also looking at this one being the same as that. Hang on, pink is not a good color. Let me choose brown. There's no good color as well. Yeah, that one is better. And this CH3 is the same as that CH3. Can follow?
Yes.
Yes.
So 1, 2, 3, 4, 5, 6. Label proton already in D2O, so not included. So should be 6. Happy?
Yes.
Okay, cool. Next.
Part D1. D1.
D is it? D for dog.
Yes.
Okay. This is about the order of substitutions. Okay, this is the story that I told you guys last time. Which one is important first? You start from methyl benzene. This is CH3. This is alkyl group. This is what you call electron donating. So it's called activating. If it is activating, which position does it direct to for their substitutions?
1, 3, 5.
1, 3,
2,
5.
4, 6. Okay. All right. Now you look at the final product. This is COOH. COOH. CH3 becomes COOH. What type of reaction is that? Very specific to benzene. Do not say it's substitution. It's not substitution. It's very specific to benzene chemistry. Anyone remember? Oxidation.
Oxidation.
This is a very special one, very, very specific. Yeah, pantang na this one for benzene. Okay, doesn't matter how long your alkyl chain, ina kira berapa panjang or how much branch it is, as long as it's on the benzene ring, you will oxidize it to benzoic acid. CO2H on the benzene ring is called benzoic acid. Now, benzoic acid is deactivating. This is deactivating, and it will direct to position 3 and 5. Agree?
Yes.
Now have a look at these. This one is 1, 2, 3, and 4. This one's at 4. So do you think you want to change it to CO2H first and then tambah NO2? Or do you want to tambah NO2 first and then CO2H? You have two choices, yeah? So step 1 could be, you could do substitute NO2 dulu. And then second one, baruta oxidation. Or you can do oxidation first and then suck the NO2. So which one would you do? Left or right? Think about your targets.
Left.
You sure?
No. Right.
Right.
Right first, okay. So if I do the thing on the right first, do you agree I will get COOH first?
Yes.
So COOH will direct position berapa?
2, 4.
Where do I want my NO2? I want my NO2 at 4. Will that work?
No.
So you know this will be wrong. Okay, do you understand why now?
Yes.
Okay, so we don't want that. Okay, and that means we want to do NO2 first because this is still 2 and 4, right? So this is okay. And then guess what? When we change the CH3 to COOH, NO2 is already there. So the CH3 becomes COOH, makes no difference whatsoever to us. Happy with the idea?
Yes.
So this is called type of reaction, yeah? The type of reaction there is substitution. The type of reaction there is called oxidation. The mechanism is electrophilic substitution. The mechanism is oxidation, which you don't need to learn in A-level. Now, the reagents and conditions are quite important. This is a classic one. Benzene become nitrobenzene. What are the conditions? Very, very frequently asked question. Always, tiap-tiap tahun kena tanya. Yes, anyone? Benzene to become nitrobenzene. It's also in the syllabus, yeah? Stated in the syllabus name. You need concentrated nitric acid, concentrated sulfuric acid, reagents. Conditions, well, you need to reflux around 60 degrees Celsius. Okay. Now, this second one is something that will have a big change from past year paper. Previously, if you use the marking scheme from the older past year paper, semua salah, because the new 2022 syllabus is very, very, very particular about this. Okay, very particular about this. If you use the old marking scheme, you will get penalized in the new paper. So be very careful about this, yeah, when you use past year paper marking scheme. Yeah? Here, you want to oxidize the CH3 on the alkyl side chain of benzene. If you look in the syllabus, very specifically, ia cakap alkaline, what was it? Alkaline KMNO4 and reflux. Okay. Do you have the syllabus with you? Or better yet, I should probably show you where in the syllabus. Let me just show you where in the syllabus are. Excuse me. Where are reactions? Just skip straight to A2. Where's the benzene chemistry reactions? I mean, this was all I covered with you before, yeah? So it's not like you don't have it. There you go. Concentrated. I mean, this was the nitrations, reactants, conditions. Oh, yeah, you said 60 degrees Celsius, okay? But the one that I was talking about was complete oxidation of the side chains, hot, alkaline, KMNO4. You see how they use alkaline conditions, but then they have to add dilute acid to give a benzoic acid. First one, second one. In the old syllabus, they just say use acidified KMNO4. Okay, so the new syllabus is very, very particular now. So this is in the 2022 syllabus. Don't say I don't tell you, yeah? And this is something that your teacher will have gone through with you, previously when you did the topic. So then you have to add excess dilute HCl. Why? Because you will get the salt. Carboxylic acid would not exist as carboxylic acid if you're in alkaline conditions. You will get COO minus. Then you add excess H plus, then you protonate to give you back the carboxylic acid. Happy?
Yes.
So this type of questions, if you see a few years back, the marking scheme will be different from this 2022 paper because this is based on the new syllabus, whereas the old syllabus, They don't care so much about the alkaline conditions, just to make you aware lah. Okay. All right. Next question.
Sir, yang alkaline KMnO4 ini for semua yang oxidation, Pak?
This is only for A2. Didn't you know in AS? Now let's go back to AS because it was last year. Where was AS? Under organic chemistry, as well as under alkene chemistry. Under alkene first, you see this is alkene, AS. Cold dilute acidified KMnO4 to form diol, dilute acidified. Hot concentrated acidified KMnO4. This is when you break the carbon-carbon double bond. Always acidified, except for that condition. What was the other one? Yeah, alcohols. Acidified KMnO4. I wonder what else. Here, acidified KMnO4. Always acidified. I mean, this is your redox titration. Not sure if you have, well, you must have done this before. Where this one go to Mn2 plus and H2O. And since you are no longer given data booklet, you're supposed to be able to balance this on your own. Yeah. This is manganese plus 7. This is manganese plus 2. So that means I must add 5 electrons. And I have 4 oxygens. So 1 oxygen, that means I have 4 H2O, 8 hydrogens. So 8, and you will see the charge balance out. Plus 8 minus 1 is plus 7. Minus 5 is plus 2. I get plus 2 on the right hand side. Purple color reagent becoming kind of pale pink / colorless as they undergo the redox titrations. Acid, acidified condition, except for when you are in the benzene chemistry, then you use alkaline conditions for the KMnO4 in order to oxidize the side chain of benzene. All good?
Yes.
So your question is it always alkaline? No. Most of the time it's acidified, except when it's in here. All right. Okay. Next question.
Question 5 part E. 1.
Is Akila there already?
Yes.
Oh, okay. Just part E, yeah. Oh, by the way, did you guys go through the mechanism already?
Yes.
Okay. Did I tell you to go through this mechanism? This is the condensation mechanism, the addition elimination. This is also new in the 2022 syllabus, and let me just tell you that it has a very good chance of coming out. Okay. And you won't find this in the old past year paper because you only started in 2022. So it's the new syllabus. Okay. But you guys, I did show you guys last week, right?
Yes.
Okay, cool. So just make sure you score the 4 marks just like that, yeah? Oh, sorry, 5 marks out of 100, just like that. Okay? Don't do silly stuff, yeah? Is it part E you wanted me to go through?
Yes.
Okay. Okay, so first of all, we look for the repeat units. And we're going to suggest the structure of the 2 monomers. So the building blocks. So this is continuous, yeah, by the way, continuous and continuous. We read the questions. Acyl chloride plus that give me an acid anhydride. And I do have an acid anhydride here. The question is, I must find what is my acyl chloride and what is my sodium carboxylate. I mean, these are my 2 monomers. They give me that. But why do I have it continuous? Because hopefully you can see, let me try and see what's going on. I think there are 2 possibilities. If I cut there, then there will be the CO2 minus. Can you see that? Because this is CO2 minus Na. But then I would need, now that wouldn't, would that work? Why is this tricky? Acyl chloride reacts with sodium carboxylate. Acyl chloride. Acyl chloride reacts with sodium carboxylate. Oh, wait, hang on. I think I got it. I think should be here. I think should be here and here. And then this one should be here and here. Okay, what is going on? So have a look at these. And then you can hopefully see here and here. Okay? Can you follow?
Yes.
This one here, C double bond OO, C double bond OO. And now we are looking at the COCl. So this is the CO, and then you have to put in the Cl, okay? So there's the acyl chloride. And there's the acyl chloride. So they haven't given you a lot of space. So you're just gonna have to be a little bit creative. Or CH2, 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 or like that. But I can move my stuff around. Not sure that you can. So there's that, and there's that. Happy with that? I've just added in the acyl chloride. That's all. I copy the exact same thing. I just put in the acyl chloride at the end. Not okay? Can or cannot?
Cannot.
Cannot. Oh, okay. Well, you gotta read the questions and let's see. It's 2 marks. Run away if you cannot. Okay. I would say better to give 2 marks up than not scoring the rest of it. Okay. If you really cannot, just run away. You can come back to it. Better to lose 2 marks than losing the whole paper. Okay. But the idea is you have to read the questions and see what comes together to give you that. You see, the whole idea is you dapat this COO, COO, CO, COO, CO. Okay, so the fact that you can see that, and then this continues COO, CO. So that means this black stuff comes from these two together. So I'm looking for these junctions. And this thing in between is just useless stuff. They're just whatever is in between. In O level, you will call this like this. Macam mana? Like that. Yeah, you don't care about whatever is in between. You just care about where the important junctions are, which is why we read the questions. We look for the big picture and not for the little things. Happy?
Yes.
Okay. So here I am going to just complete this thing, CH2, C double bond O minus and A plus. I usually write my ionic salt like this, but of course you're more than welcome to write like that also. I mean, you can write O and A, but you know it's not covalent. It's definitely ionic. Just like in AS, it's called carboxylate because this is ionic. That's why I write ionic. If you don't show the chart, it's fine. You can just write O and A, just like the question. Perfectly fine. And of course, this is about biodegradable. So if you look in the syllabus, biodegradability, you can say by actions of bacteria, or because it's about bio, right? So it's about by biological organisms. So how do biological organisms metabolize stuff or break down stuff with the help of enzymes? Because enzymes will be biological catalysts. Okay, all good?
Yes.
Okay, cool. Next question. Yep, next question. No more question. That's all.
Question 1. Yang gives energy.
Okay, cool. Wait, the first part was all right? E part 1 was all right?
Yes.
So it's just the second one that you need help working out?
Yes.
All right, okay. So the first thing we need to do, we know that delta G is equal to delta H minus T times delta S. But we don't have delta S, so we need to find delta S. Now we're given this equation here, and we're given a table of entropy values. Entropy change means going from left to right. How has the entropy changed? So it's going to be sum of the entropy of products minus the sum of entropy of reactants. Going from left to right, what happened to the entropy? Here we have 2 ammonia, so 2 times 192 plus 1 of these barium chloride, so 1 times 427, and 8 water, so 8 times 70. Entropy for 1 mole of water. But then this is 8 mole of water, so it's multiplied by 8. Okay, minus another big bracket, the reactants, the barium hydroxide with octahydrate, so there's 1 times 427, and then there is 2 of the ammonium chloride, 2 times 95. Press your calculator very quickly, but very carefully. So I get 1371 minus 427 plus 95 times 2. Are you guys getting the same thing?
So,
Did I do anything wrong?
Produk yang 427 bukan patut 203 kah?
You are right. Okay, I misread that. That should be 203. You see, things like this, if you don't really read carefully what you're writing, you will mess up. And when you mess up, there will be no turning back. So you don't have much time to check your work. Yeah? So be very careful when you're doing this. Okay. So 1147 minus 617. Calculator show me 530. Is that correct? Come on, check your calculator. You need to learn how to press the calculator correctly.
Yes.
Is it correct?
Yes.
It's wrong. Calculator cannot think, okay? Positive joule per Kelvin per mole. That's the unit for entropy. Okay, calculator cannot think. Okay, people have to think on behalf of the calculator. People have to think, okay, and decide. Now, delta G is equal to delta H minus T times delta S. The T here is in degrees Celsius, but the T in here, because of the unit being in Kelvin, joule per Kelvin per mole, I must multiply by Kelvin. Okay, so that one is equal to plus 273. They give me 298 Kelvin. My enthalpy change on top there, plus 133 kilojoule per mole. I must emphasize that delta G is in kilojoule per mole, and this one is in joule per Kelvin per mole. So I already convert the temperature from 25 degrees Celsius to Kelvin, but I must remember to convert this joule per Kelvin per mole into kilojoule per Kelvin per mole. Happy with that?
Yes.
So the key thing here really is the bookkeeping. Number 1, the units. Number 2, the bookkeeping involved having the same unit. Kilojoule per mole. This one, when you divide by 1000, it becomes kilojoule per Kelvin per mole. Multiply by Kelvin, then you're going to get kilojoule per mole. Kilojoule per mole, your final answer is in kilojoule per mole. Just press a calculator, and what do you get?
Minus 24.9.
And that will be wrong without the final unit. Sign, value, and unit. That's a given. Yes, the unit is given there, but you have to learn to write the unit If you don't write down the unit here, later on you might not be able to check back your answer very, very easily. Okay, just so that you get the 3 marks. Okay, all done. Next questions. Well, we have around 4 minutes, so probably another 1 or 2 more questions.
Seven A. 7A sir. Yang part 2.
Okay, why don't you name me all the functional group first? Can you name me all the functional group in here? What functional group do people see? What do you see? Come on, name it. One, anyone? Faster we do this. Fast. Amine. Is this the amine?
Yes.
No. Is this an amine?
No.
Yes. This is called a tertiary amine. I mean, in biology, you also learn tertiary and quaternary amine. Tertiary amine has no hydrogen because the nitrogen form 3 covalent bond. This is not an amine. This is called a phenylamine. There is a topic, special topic called phenol. Phenol is when OH is bonded to benzene. They don't call it alcohol, they call it phenol. When you have NH2 bonded to benzene, they don't call it amine, they call it phenylamine. It's a topic on its own, yeah? What is this group here? This one. Ester is correct. What about this group here? Yep, so you do have a benzene system, you do have an aromatic ring. So yeah. Can I write down alkane? Because I do have all these CH2, whatever thing. Is alkane included?
Yes.
What do you think? So there was, who was that? There was Isa, right? How about the other two? Can I include alkane?
Yes.
Okay.
No.
Sorry, yes or no?
No.
No. Okay. How about the other one?
Yes.
No. Yeah. This is AS 2022 syllabus. New syllabus there, new one. Where was it? There you go. 2022 syllabus 13.1, the very first one, the very first one stated in the syllabus. Understand that alkanes are simple hydrocarbon with no functional group. Name the functional group. Alkane does not have a functional group. Happy? Don't say I don't tell you. The syllabus is everything. And if you don't use the syllabus, you're going to be in trouble. Okay, now a molecule of procan has 13 carbon atoms. You want to find sp, sp2, sp3. What's the bond angle in sp3? Come on, hit me.
120.
Nope, that is wrong. 109.5 degree, as sp3 is tetrahedral. Think about it as alkane. And then sp2, what's the bond angle?
120.
This is your trigonal planar, and this is your alkene. And then when you go to sp, what's your bond angle?
1.
It's 180 degree linear. And this HCN is in your topic 3. It's in structure and bonding, dot and cross diagram, linear, 2 bonding pairs, 0 lone pair. This should have been, I don't know, April 2021, May 2021, shape of molecule, something like that. Okay. Anyway, so ProCAD, let's have a look at ProCAD. Okay, I'm gonna have to remove this thing. Let me just cut it. Okay, we're looking at ProCAD. This is definitely sp2. sp2. Well, everything inside benzene is sp2. That's what I can tell you, right? Case study, right? So there's sp2. This is sp2 also, as that is a trigonal planar 120-degree carbonyl. You must know that, right? You're looking just for carbon atoms. So I think that is safe to say that that is all the sp2, but then be aware that there is the 2 there. So this is a tetrahedral and tetrahedral because CH3, CH2. Carbon form 4 bond. Carbon form 4 bond, 2 hydrogens, 1 to nitrogen, 1 to carbon. So there are altogether 1, 2, 3, 4. 4 times carbon sp3. These 2, they are sp3 and sp3. So another 2 more. And that's it. There is nothing which is linear. And so there will be 0, which is sp. sp2, there will be 1, 2, 3, 4, 5, 6, 7. 7 sp2. And then there will be 2 plus 4, which is 6. So 7 plus 6 is 13 carbon. Oh, there you go. 13 carbon altogether. Happy?
Yes.
Sure. And that is why there's 1 mark, because you should be able to do that in 1 minute. If you cannot, part A is usually the easiest because it's AS chemistry. Okay, all good?
Yes.
Do you need to label some stuff? Can I wrap that out? No, actually, I'm not going to wrap it out. It's fine. Okay, cool. All right, it's 9:33, so I think I'll leave it there. It's 1 hour now. So yeah, I'll see you guys again next week. And have you guys pretty much finished this paper?
Yes.
Oh, okay. Do you want another paper next week?
Yes.
Okay. You guys are still at Alaf, right? If I ask them now, can you ask them to print them for you?
Yes.
Okay, cool. I'll send it to them. And then you guys just try that paper before I see you guys next week, so that it's better that you come up with questions rather than on the spot you haven't tried. Make sense?
Okay.
Okay, cool. All right, cool. I'll just send the document to them now. So you only have the March 22, right? Have you gone through the March 22 though? Have you gone through the March 22 paper? I mean, last time I printed for you, but you might not have gone through all of them, right?
Yes.
Okay, you try that. You try that first. Have you guys finished that?
Not
Okay, you should do that between this week and next week, and then next week I'll give you guys a new paper again. Okay, make sense?
okay.
You guys definitely have this. I think you guys definitely have this. Did I print this for you?
Yes, sudah.
Okay. But then you guys haven't done as much as this other paper, right? So perhaps you guys can spend some time on this.
Okay.
Okay. One more thing. Do you want paper 4 or paper 5 the next time I give you a printed paper?
4.
You still want paper 4? You don't want to start paper 5?
No.
Oh, okay. So you should start paper 5 on your own, yeah? Paper 5 is quite easy to score if you know what you're doing. Paper 5, experimental planning and stuff. Okay, cool. When I see you next, I'll print out another paper 4 for you guys. But in the meantime, between this week and the time I see you next week, so do try the rest of this March 22 paper so that you can get used to the idea of the new syllabus. All right, take care then. I am off and I'll share the PDF in the Google Classroom very, very soon. Okay, take care everyone.
Thank you,
Okay,
sir.
sir.
Okay, bye-bye.